Okay, so sometimes when we're solving equations, we're going to have an equation where our variable is being raised to an exponent or raised to a power. So if we want to clear the exponents, we're going to do that by using roots. Roots in exponents are inverse operation. For example, the square root and squaring something are inverses. The cube root and cubing something are inverses. They undo each other. So we're going to use that fact to help us solve these equations. And kind of like the last section where we had to notice if it was an even index or an odd index, same thing is true here. If we're doing an odd root, then we're going to use the odd root property. That basically just means we take the root of it. That's going to be our answer. It's going to be a little bit different when we have an even root. When we take the even root of a number, we have to do plus and minus, and I'll show you why when we get to that one. So on example 449, I have the x to the 5th equals 32. To undo that power, I'm going to take the 5th root. The 5th root and x to the 5th cancels, and I'm just left with x. The 5th root of 32 is 2, so my solution is x equals 2. And extraneous solutions won't exist for these types of problems, so once you solve it, that's just your solution. Okay, so when we're dealing with an even power, let me give you something we're pretty familiar with. X squared equals 9. If we think about what values of x we could plug in to make this true, well, I could have x equals 3. 3 squared is 9. Or I could have x equals negative 3. Negative 3 squared is also 9. So when we have an even power like this, we have to take into account that it could be the positive or the negative of that root. And that's true with any even power of 2, 4, 6, 8. So for example, 450, I have x to the 4th equals 16. So I'm going to take the 4th root. So I get x equals plus or minus. When we have an even root, we have to put plus or minus. And the 4th root of 16 is 2. So our solutions are positive 2 and negative 2. On 451, I'm going to take the square root of the left side, square root of the right side to undo that power of 2, and I get 2x plus 4 equals plus or minus 6. Okay, so here I'm going to kind of just split this up into two equations. I could have 2x plus 4. We said it could be positive 6. I could have 2x plus 4 equals negative 6. Now we're just going to solve both of those. If I move this 4 over, I get 2x equals 2. If I divide both sides by 2, I get x equals 1. Similarly, on the right side, if I move that 4 over, I get 2x equals negative 10. If I divide by 2, I get x equals negative 5. So we get x equals 1, x equals negative 5. But if you notice on example 452, we have a square root, or a square, so I'm going to use a square root to undo that. If you notice on our right side, we have a non-perfect square. 45 is not a perfect square, so we're not able to just get an integer like we did on the last one. We're going to have to just simplify that non-perfect square as much as we can. So the left side, we get 6x minus 9 equals the square root of 45. I'm going to come over here and simplify the square root of 5 and use whichever method you prefer. I've got 3 and 15, 3 and 5, so I'm going to take out a 3. So I get equals plus or minus, don't forget your plus or minus, 3 square root 5. All right, my goal is still to solve for x, so I'm going to add 9. So I get 6x equals, careful here, I can't add 9 to this. This 3 is stuck with that square root of 5, and they're not like terms. So I'm just going to write this as 9 plus or minus 3 square root of 5. Okay, my x is almost by itself, so I'm going to divide both sides by 6. So I get x equals, and let's see how we can simplify this. We can divide 9, 3, and 6 all by 3. So I get 3 plus or minus 1 square root of 5, or just square root of 5, divided by 2. We can leave our answer written just like that. All right, on 453, first thing we're going to have to do before we take the cube root of both sides is we want to isolate that x plus 4 to the third power. To do that, I'm going to move that 6 to the right side. So I get x plus 4 to the third power equals 125. I'm going to take the cube root of each side, and I get x plus 4 equals the cube root of 125 is just 5. When it's an odd root, we don't have to worry about the plus or minus. It's just that number. So if I solve for x, if I subtract 4, I get x equals 1. All right, and then one more example here. I have 6x plus 1 to the second power equals 6. Well, first, let's isolate this. Let's move that 6 to the right side. And I get 6x plus 1 squared equals 4. This one's nice because 4 is a perfect square. So when I take the square root of each side, I get 6x plus 1 equals plus or minus, well, the square root of 4 is 2. Okay, so same thing, we can write our two equations here. And we can go ahead and solve them because we had a perfect square. So I've got 6x plus 1 equals positive 2. 6x plus 1 equals negative 2. If I solve the first one, I get 6x equals 1, or x equals 1/6. For the second one, if I move that 1 over, 6x equals negative 3. If we divide both sides by 6, I get an x equals negative 1/2. So when we're solving equations that have x raised to a power, we use that same root to cancel that to solve for the x.